Yes. Oh, what a good boy. Thank you, Mr. Milo. I love you so much. You're my best friend. Thank you. Well, hi there. I'm Professor Dan, and that was Mr. Milo. He's my best friend. And he may look like an ordinary dog, but he's not. He's a science dog. And what makes him a science dog? He's always asking questions. He loves to ask questions. And if you like to ask questions, why don't you come along with us? We're getting ready to head to the classroom and learn some interesting stuff. So come on. Well, hi everybody. Thanks for coming up to the classroom. So guess what me and Milo were talking about the other day? We were talking about, well, I can show you a little bit about what we were talking about. So let me show you that and then we'll come right back. Hey, Mr. Milo, time to eat, buddy. Ready to eat? Dog food. 1, 2, and yes, I made sure I gave you 2 cups. Are you gonna come here? Hey, I got an idea. Watch this. Milo. Come here. You wanna see this? Come here. That's okay. Look. Your dog food floats. Your dog food floats. Do you know why it floats? It's because it's lighter than the water. The water's more dense. What I mean by more dense? Well, that's a good question. Since you got a mouthful of food, why don't we go up to the classroom and we'll talk about it? Okay? Great. Okay, so that's what we were talking about was why was his dog food floating in his bowl of water? And I was trying to explain to him that right then the dog food was dry, so it's actually lighter than his water. And as the dog food absorbed his water, remember we talked about absorption, capillary action? Remember we talked about that? Anyway, so as it absorbed, it got heavier than the water, so it slowly sank down to the bottom. So that's what I wanted to talk about today was density. It's a word called density. And density, it can be with liquids, it can be with solids. Let me give you a quick example. For a solid, density might look something like this you could compare. One, we have a sponge. We've seen this a couple times. My favorite blue sponge, okay? And density, you can kind of look at it and see that it has a lot of holes in it. So there's a lot of air in there and it's kind of hollow. And it's very, very, very light. I can drop it and it doesn't make any noise hardly at all. But it's really super flexible and it's light and it's like whipped cream. So we'd say this has low density because it's so soft I can push into it. I can take my finger and push down and you can kind of see how it just kind of squishes, okay? So the sponge. On the other hand, we have a brick. And this sucker is heavy. This is a big old brick. Actually, this brick, believe it or not, I keep it on a special shelf because this brick, you can kind of see there's some words on it. This brick actually came out of a racetrack. Back in the early 1900s in Indianapolis, Indiana, there was a racetrack called the 500. Maybe you've heard of it. Every May, every year, they have a race there called the Indianapolis 500. And this is one of the original bricks that was in the racetrack back in 1911. So this is a really, really old brick. And it's a really, really heavy brick, as you can hear. So, this is called dense. The word dense. This is very, very dense. The sponge is very, very, what you'd say is light. It's not as dense as this brick. Ah, that hurt. So, much better to put the sponge up there than to hit the brick. So that's how things that are solid, like these, like the sponge, and the brick. That's how things that are solid we can classify as being dense or just how dense it is. This brick is very, very dense. It's really hard. You can't poke through it. The sponge is really soft and you can poke. So the sponge is not as dense as the brick. And that's kind of one of the things you can tell about density is weight. When something weighs a lot, it's usually very dense. And when it's very light, it's usually not as dense. Okay, but it also depends on size. If I had a sponge that was as big as this house, I couldn't pick it up because it would be very, very dense. compare it in size for me to pick it up. So something the same size. If this brick was the same size as the sponge, it would still be more dense than the sponge. Okay, so that's density as far as the solids go. But we're going to talk about liquids today. So let me get this back over here. Ugh. Oh! Whew! That was hard. Okay, so that's solids. Got it? Let me show you the word density. It's a pretty simple word that you can probably, when you see it, you'll know it. Oh, did you guys see my sign? It says, if you don't do it, who will? So if you don't figure out a way to get to, say if you want to go to, I don't know, a planet somewhere like Mars, if you don't figure it out, who will? Maybe somebody, but we can do something really simple, like opening a door for somebody. If you don't help somebody, then who will? Why shouldn't you help? So if you can help somebody, maybe open a door and help them in, you should, because if you don't, there might not be anybody else who will. Or maybe picking up trash. If you see some litter on the ground, if you don't pick it up, maybe nobody else will, and it's just going to stay there and be litter. So if you don't do it, who will? So it's always important to think about that. Maybe I should do it, because maybe nobody else will. So, okay, we're going to get rid of boogie, boogie, boogie. We're going to erase. Gone, just that easy. And the word density. So, let's see if I can spell that. I have problems sometimes. S-I-T-Y. Density. Voila! The word density. It's not a real big word. You can probably remember it when you see it. But density tells us about how, kind of, if you remember, like how thick something is. Okay, and that's what I'm going to show you, is liquid density, what it means as far as liquids go. So, let's check it out. All right. So, got some cool things. First of all, here's something you can try at home that your mom and dad can help you with. It's really, really cool. At least I think it is. So let me show you what we're going to do. So, all right. First of all, we need a glass. Very simple, very easy. That you got. So here's our glass. I'm going to put it right over here. Glass, it's empty. So we need to put something in it. And what we're going to put in it, let's do this. I'm going to use this one instead. I have a cup, measuring cup. We've talked about measuring cups before. This is a 2-cup measuring cup. What I'm going to do is put about a cup into this little glass here. So let me go ahead and put it in. Oh, that's pretty cool, isn't it? All right. So that doesn't take much to entertain me. What can I say? I'm a simple guy. All right, so we put that there. Next, we're going to take an egg. You probably got one of those at home too. Okay? Nothing special, and just take it out of the refrigerator. I have one right here. Voila. Uno ego. Uno ego. One egg, right? I'm bilingual. What can I say? You know, I'm multi-talented. So we have one egg. What do you think will happen if I put this egg in this cup of water? What do you think will happen? Remember at Easter? Do you ever make Easter eggs and you put them in water and stuff? What do? Well, I'll show you. Watch. You take the egg. Oh, my fingers really don't fit in there, so let's do this. I'm gonna put the egg right here and let go. What happened? The egg sank. Sinkola. It went to the bottom. It's dragging dirt. It's all the way. Yeah. So you get the idea. It's at the bottom. The egg sank. So the density of the water, how thick it is, you know, it wasn't very thick to stop an egg. So the density of the egg was greater than the density of the water. So the egg sank. Now, let's try something different. If I can get this egg up. My fingers are too little, too big. Too little, too big. The glass is too little. My fingers are too big and fat. So here, I'm gonna make a mess hell, I'm gonna end up with a hard-boiled egg because that water is kind of warm. I can't get it up. There we go, there we go. Oh, it's so hard being me. So I can get maybe, if I can just turn it up, there we go. Maybe you can do better than me. So I got the egg out, okay? Dry it off. Okay, so I'm gonna put the egg down right here. You can all see the egg. Got it, good. Okay, now we're gonna try something different. We're going to change the density of the water. How do you do that? I'm gonna show you. So what we do, we're gonna take, you know what? You've seen this before too. Maybe if you've seen one of the other videos. You know what this is? It's a measuring spoon, that's right. And this, this measuring spoon, it is, as you can see here, 1 tablespoon. Let me get it out of there we go. 1 tablespoon. So what we're gonna do is we're gonna take 2 tablespoons of salt. This is just everyday salt you guys may have in your kitchen. And we're gonna put 1 tablespoon in, okay? And then we're gonna fill up another tablespoon. There we go. Shake it a little bit, make sure it's even, okay? And we pour that in there. So, 2, 1, 2, 3, no, dos, just dos. 2 tablespoons of salt. Now, I go there and I take my little measuring, it's not measuring, it's a stirring, it's a spatula, it's called a spatula. They're kind of rubber and you can use them to scrape pots and pans. So we're gonna take that, we're gonna use it to mix up the salt. So we gotta mix it up real good, make sure all the salt is dissolved. You know what that means? When the hard salt, the crystals, actually melt, the structure of the molecules inside are changing form, and now they're melting and turning into the liquid. So we stir it a little bit because we want it all to dissolve, to melt. We want all that salt in there to melt. So, there's a place over in the Middle East called the Dead Sea. And the Dead Sea, believe it or not, it sounds kind of weird. Why would you call any place the Dead Sea? It's because it is so salty. It's so salty, incredibly salty. It is so salty that nothing can live in it. It dies. It's just too salty. It's not like the ocean around the United States where you can go swimming and there's fish and everything. The Dead Sea, it's kind of inland. It's kind of like stuck in land. And there's land all around it, but it's really, really big. But there's so much salt in it, nothing can live. So it's called the Dead Sea. So, we didn't create that. It's a little small for that. But anyway, so we have the Dead Sea. So, you can see it was kind of white because there were air bubbles in it. Now the air bubbles are all leaving. So it's becoming clear again. Okay, we have the same egg. See, no tricks, same egg. You saw me pick it up here. Now, what do you think is going to happen when I put the egg in now? Well, let's find out. Oh, it's cold. What? Oh, it's too cold. Don't put me in there. Oh, now the egg's complaining. Okay, here we go. 1, 2, 3. What happened? The egg is floating in the cup of water now. It's not on the bottom. It was sitting on the bottom before. Now you can see it's floating. I have a floating egg. Magic! No, not magic. Science. And that's why Milo likes this stuff. So, the reason the egg is now floating in the water, same cup of water, I just put salt in it. I put a lot of salt in it. Trust me, you do not want to drink that. It has so much salt in it that it changed the, what? Density. It changed the density. But what did it do to the density? It actually made the density, that's not good English. It actually made it more dense. Okay, it made it thicker, made the water thicker. So now the egg is actually less dense than the water. So it floats. So remember I told you about the Dead Sea? If you go out in the Dead Sea, first of all, do not drink it. But if you go out in the Dead Sea and lay down and just put your arms on and lay still, you'll float. You'll float nice and high because the density of the water in the Dead Sea is much more dense than water in a swimming pool or the ocean. You float much easier because the Red Sea, the water in it, is very, very dense. So, there's another place here in the United States called Salt Lake City. And guess what? There's a giant lake there that's made of, you guessed it, salt. And it has the same problem. It is so salty, you can actually go out, and it smells so bad there. Shh, don't tell anybody. But if you actually go out, you can float just really, really easy. You float really easy on the water. You don't want to sink. Your body just floats up on the water because there's so much salt in it. It makes it very dense. The density of the water is much higher, again, than a swimming pool or maybe a lake or the ocean. Okay? So that's something to kind of remember. So that's a great experiment we just did here. You can do it at home. You can show your mom and dad. All it took was a little bit of water, some salt, 2 tablespoons of salt, and just a regular egg. You don't have to boil it or anything. Just take it out of the refrigerator and stick it in there. And it's a great little magic trick to show your friends, or again, trick out your mom or dad when they come home and say, look, I can make an egg float in this water. They'll be totally amazed. Then they'll probably tell you to go boil it and we're gonna have eggs for dinner. So, okay, I got another little demonstration we can do that's really fun too. So, let me take the egg out of the way. It's gonna be my dinner tonight. I like hard-boiled eggs. All right, so we got the egg out of the way, egg out of the way, egg out of the way. Clean up my mess, because you know how I am with messes. I do not like them, Sam I am. I do not like green eggs and ham. I do not like them on a plane. I do not like them on a train. And we're gonna stop there because I don't know the rest of it. So let's get that water out of the way. I got my famous paper towels. We're gonna lose that one. We'll keep that up. That there. Okay, it's good. We're good. Okay, next. This is a really cool thing you do too. It's gonna show the different densities of different liquids, but we're gonna put them all together to show you how it actually works. So let's do this. First things first. I have a glass. See? Bueno. Okay, so I have a glass right here. We're gonna put it right there, right here, right there, right here, okay? Here, let me adjust this real quick because I need some adjustment. Sorry. Okay. You get, let me try to fix this a little bit. There we go. Okay, much better. So we have the glass. Excuse me. Sorry about that. Okay, so first things, I'm going to take the water again, which I have here, in my 2-cup measuring cup, and I'm going to put a little bit food coloring in it. This is just some blue. It's going to help us see things a little easier. It doesn't matter how much, but you can do this at home. Get your favorite food coloring. Ask mom and dad first. This one is blue because I like blue. As you see, my walls are blue. So I like blue. But you can use whatever color you like, whatever color you have. It's up to you. So now we are going to stir this up, and I'm looking for a paper towel to wipe off with again because I'm going to make the mess. Okay, so I've stirred that. We cleaned that. Now, first thing I'm going to do is take my cup of, it's just blue water because it's kind of pretty. Ooh, it kind of goes with my shirt, doesn't it? Blends in, it's camouflaged. So, okay, so I'm going to pour it in the glass. And we're going to put about a third of the cup in there. We're going to do about that much, okay? So, that's about a third. Okay, so we have water, right? Right, that's what I told everybody, it's water as far as you know. Okay, water. Next thing we're going to do is, I'm going to take one of my most favorite things, me and Pooh Bear, we love honey. He loves it more than I do, but I really, really like honey. So I always have honey at home. So I've got some honey here. Now, would you say honey is a liquid? Because you can pour it out. So I'd say it's a liquid, wouldn't you? It's just a very thick liquid. So let's open it up and we'll put some in. My pot seems to be out of honey. Oh, Magic Bear, please open your head and give me honey. It's my little bear friend. So, I'm not getting any honey out of him. I bet I know why. Daggone it, they did it again. They put another lid on the container and I can't get it off hardly. See? Another one of these silly sticker things now. All right, so, oh, this one's easier. Oh, I got this. I got this. I got this. Don't look. Nothing happened. I love honey. Okay, so we've done this. Now we're gonna put his hat back on. Okay, now we can open it. Now, a little bit of honey. We're gonna put in there. So let's put some honey in here. Now, what do you think about honey? Do you think it's more dense or less dense than water? What do you think? It's pretty thick stuff, and what did we talk about? Things that are usually heavier, you know, are usually heavier. They go down to the bottom of things, right? Like a rock. If you do like a rock, it'd go down to the bottom. So we're gonna put honey in here, and I feel like I'm wasting my honey. I don't wanna waste my honey. Okay, so there. We put honey in. What's happened? Wow, okay, you can check this out. Pretty cool. Water, honey, honey, water, water, honey, water. The honey went down to the bottom because it's more dense than the water, right? Excuse me, I'm sorry everybody. So, we have honey, we have water. Next, see here. Now we have here, this is oil. This is, it's called canola oil. It's used for cooking. You can use vegetable oil if you have at home. Whatever, it's usually in a container or bottle, plastic bottle like this. So we're gonna take this, and now we're gonna pour this in ever so gently, and what do you think is gonna happen? Do you think it'll mix it all up? Do you think it'll come to the top? Do you think it'll go down to the bottom? What do you think? Let's find out. I'll pour this in really easy. You know, but before I do, I want to talk about canola oil. Is very healthy for you, actually. It's more healthy than vegetable oil. So if you have a choice, go with the canola. There's other oils that are good too. Not saying bad, but I do know that the canola oil is a little bit better than vegetable oil. Excuse me, I have a leak on my glass that I have to clean up because I don't like messes. Okay, so we'll try this again. Excuse me, we're gonna put it in. But before I put it in, I wanna know for sure if you've decided, is it gonna stay on the top, go to the bottom, or mix everything up? What is it? But, no, I'm kidding. All right, here we go. We're gonna put it in. Go in, go in. Uh-oh. Uh-oh. Uh-oh, ooh, that's really cool. Can you guys see what's going on there? It's kind of making bubbles on top of the water. Look at that. That's awesome. That is so cool. Do you know what it reminds me of? A lava lamp. Have you ever seen a lava lamp? They're really cool. You've probably seen them in the stores. You may even have one at home. But the lava lamps has to do with density of fluid. It has different fluids in there, just like we have different fluids here. And you can see the oil went all the way to the top. That's because the oil is lighter. It's less dense than water. What do you know? And it's less dense than honey. So it came up to the top when I poured it in. Pretty awesome, huh? So now you know, vegetable oil, canola oil, just oils in general are lighter than water. But I was telling you about lava lamps. There's two liquids in there, different densities. That's how, when you turn them on, you see these big blobs kind of moving and floating around. And they go up to the top and then they come back down. Then they go back up. And they're really cool looking. Two different liquids with two different densities. It's like mixing oil and water. The oil makes all these little bubbles in the water and they try to get away because they don't mix. So they finally go up to the top to get away. So that's why you have this separation. So what do you think about that? Again, you can do this one at home. you have honey, water, and oil. So, I thought that was pretty awesome. Are you nuts? I'm not drinking this. Oh my gosh. You guys been watching me too long or something. I'd never do that. That's, oh. Okay, so what I have next is over here. I have, last thing, real quick. I know this is dragging on forever. See, everything I did. I got one thing left to show you that's like really, really awesomely cool. Okay, so to show you about density, I have here, these are Skittles, okay? And I have a ring of Skittles. Ring of fire. Okay, no, got ring of Skittles. And they're so pretty. And what are Skittles made out of? Do you know? They're made out of sugar. And what does sugar do when it gets wet? Sugar has a tendency to melt, kind of like salt. So here's what we're going to do. I'm going to give you an example. See, I got a nice pretty ring, right? I'm going to scoot it up here. I'm going to turn the camera down just a little bit here, guys, so you can get a little better view maybe here of what's going on. Okay, so there. So check this out. I'm going to ring of Skittles, and you can do this at home. You can get Skittles or M&M's. Skittles work the best, I think, but then again, I like Skittles. If you're wondering where all those Skittles came from, I got a few left, you might say, if you remember from another little video we did. I got 2 more bags of these, so I got the Skittles covered. So, Skittles, 2 thumbs up on those, baby. All right, check this out. So, we have the Skittles there. Now what I'm gonna do is just take, this is just regular old water. It's a little warm, I got some warm water. But watch this. I'm going to gently pour the water into the plate of Skittles. And let's see here what happens. Okay, here we go. Now, this might take a minute or dos. So, for all you bilingual people out there, that's as bilingual as I get. Si and dos. Tres. Uno, dos, tres. You know what? My wife actually, she's Venezuelan, and she's been helping me with my Spanish. I'm not very good, she says. And I agree with her, I'm not very good at that. But I am trying. So it's important to try things. Even if you don't think you can, you try. It's really important. So, what's going on here? Can you guys see that? Can you see this? I mean, I can't pick it up and show you because it's liquid and it's gonna run everywhere. But can you see what's going on here? You see the colors melting? See them running across the plate like they are? It's really cool. It takes about 2 minutes, 3 minutes, and the colors keep melting. And what's going on is the water is mixing with candy. It's just pure sugar, guys. Skittles is nothing but pure sugar with some color on it. So as the water is actually dissolving the color off of the sugar. And the sugar's starting to melt too. But as it's dissolving, check it out. Look what it did already. Its density, it's becoming more dense than the regular water. So it's flowing downhill, down to the center of the plate, because the center of the plate's lower than the top edges. So the color, the sugar actually, is more dense than the surrounding water. Same idea, as the salt in the water made it more dense, the egg floated. The colors are more dense, so they're going down the plate. Well, the sugar's more dense, it's just taking the color with it. The sugar's traveling down, so it's pulling it down in a line. And in time, if you let it sit here long enough, these colors will all start to melt and dissolve together. They'll start blending in time. But right now, they're kind of separated, and they're really cool to look at. That was something I wanted to show you, that again, you can do this at home, and it's really, really awesome looking. It's so pretty. It's worth a bag of Skittles, trust me. When you go to the store, just ask nicely if you can have a bag of Skittles because you want to do a science project. Mom and Dad says no, say, okay, thank you. But if they say yes, you can get the Skittles, and you can do this at home with a plate, a little bit of water, not too much, you just put enough so they touch the bottom of the Skittles. And then they'll all start to melt and you get these awesome colors, right? Okay, oh, something else I wanted to show you was, okay, we're gonna go ahead and move this because this is just awesome, and I need to move it though, unfortunately. Now it's all gonna get mixed up. Okay, so I'm gonna put this down here, and hopefully Milo will not hit it because it will end up all over the floor. Thank you, Milo. Okay, so I want to bring this glass back, and let's tilt the camera back up here real quick. Okay, so we have the glass, right? Now, what I wanted to show you was one more thing. I have here a ping pong ball. We've seen these before. I know you have if you've been watching me. I love ping pong balls, but check this out. What do you think is going to happen when I put this ping pong ball in this oil? What do you think is going to happen? Well, let's find out. It floats. Are you really surprised? The ping pong ball is less dense than the oil, so it floats up on top, right? Less dense than the oil. Okay, now what do you think would happen if we put, say, I don't know, maybe 40 ping pong balls in there? Do you think they'd be heavy enough to sink or float? I don't know. Well, what about just plain water? What do you think would happen then? I put this around here like that. You can see we have just a little bit less than 1 cup. If you can see that, trust me. Oh, here, I'll pull this back so you can see. I'm gonna pull this back here too. Okay, so you can see these. Now, if we put like say 40 ping pong balls in these, what do you think would happen? Well, it just so happens I have a string hanging right here. And this string is just saying, pull me, please, pull me. Can you hear that? I can hear that. I don't know. Sometimes I hear things in my head that other people don't hear. I'm hoping you all hear this. Because when he says, pull me, please, pull me, I'm hearing him say, pull me, please, pull me. So I think we need to do him a big favor. We're going to pull the string and see what happens here. So, help me count. Bilingual here. Dos, tres, dos, uno. Okay, so that was a failure because none of the ping pong balls went in here. I thought maybe a ping pong ball or two would go in, but nada, nothing, no help. Leave me hanging here, guys. They're all over the floor. They're in the plate with the Skittles, but they're not in my cups. I got 40 ping pong balls laying around here. So that was a fail pretty much. But anyway, it would have been kind of cool to see what happened. So I got like lots of ping pong balls. I love my ping pong balls. So does Milo. I gotta watch him because he likes to chew them up. So anyway, guys, I hope you had a lot of fun. I hope you got to learn a few things about density in liquids and even in solids we talked a little bit about. But you have different densities in your liquids. It just depends what they are. So you can experiment at home. If you find, always ask mom or dad if you can do these things. But you can try some different liquids and see what happens. Maybe you try some dish soap. It's a lot like honey, but I don't know. You try it out, see what happens. You can try some pancake syrup, see what happens. Maybe a soft drink or fruit juice, and mix them and see what happens. That's how you learn. You try different things, guys. I can't do everything, but I can get you started. So again, if you guys had some fun with me, I hope you learned some great stuff. So if you like what we did, hit the like button somewhere around here. I don't know where, somewhere, I can't see it. I don't have it up right now. And the subscribe button somewhere over here. I don't know. If you had a good time, hit those things, become part of our family, have some fun with us. And until I see you guys next time, have a great time, ask a lot of questions, always ask why, just like Milo does. So until next time, and I think Milo's going to say bye too here in a second. So I'll see you around. Bye-bye, guys. Did you get your ball? Did you get your ball? Did you get your ball? Did you get it? Did you get it? Yes, you did. You want to tell everybody bye-bye? You want to tell everybody bye-bye? Tell everybody bye-bye. Bye-bye, Milo. Bye-bye. Bye-bye.